Hello, thank you for joining me today for a presentation on the beginning phases of my senior project. My project is the design of an optimal construction resource layout to improve field worker efficiency at Webcor Concrete Group. My name is Fiona Blackburn, and I am a fourth-year industrial engineering student at Cal Poly San Luis Obispo. I will begin my presentation today by discussing some background information on my client, Webcor Concrete Group, as well as the problem statement that they have identified. I will then evaluate the current state, as well as discuss the literature review, which will inform my design moving forward. To continue, I will share with you the objectives that I have for this project, as well as the industrial engineering tools that I will be applying. Finally, I will discuss how I will be moving forward with this project over the next few months. My client for this project is Webcor Concrete Group. Webcor was founded in 1971 and currently has approximately 1,000 employees, making them one of the largest builders in California. They are headquartered in San Francisco, but have regional offices throughout California and also in Hawaii. However, the scope of this project will focus primarily on the construction of new housing, which Webcor is facilitating on the Cal Poly campus. The problem statement for my project is as follows. Construction labor is very expensive, and with large crews on large projects, the cost of wasted or unproductive time translate to high costs and reduced profits. At Webcor Concrete Group, the management has noticed a high level of field worker inefficiency, especially between the end of a worker's break and when they resume productive work. They aim to follow the 30-30 rule, which states that everything a field worker needs should be accessible within 30 seconds or 30 feet, but they do not always accomplish this. Webcor wishes to utilize their field hours 5% more efficiently through a case study of current shortcomings and recommended improvements at the Cal Poly San Luis Obispo housing construction site. I began my project by evaluating the current state of the Cal Poly construction site. This involved meeting with the assistant superintendent and doing a site walk to determine where everything is currently located. I found that field worker inefficiency is currently attributed to ineffective site resource layout and workers not having necessary tools accessible. For example, if a worker needs to use a power tool, but does not have an extension cord on hand that is long enough to perform the necessary work, they may have to walk across the site to go find a longer extension cord, which amounts to a lot of wasted time. Currently, each foreman on the site is responsible for their own job box, which includes tools they use on a regular basis, such as saws or drills, and each foreman decides where to place their own job box on the site. There are also 2 Conex boxes with consumable materials that are placed centrally on the site for all of the foreman teams to use. In addition, I performed a business case for pursuing this project. Webcor informed me that last year they used approximately 1 million field hours. Their field workers cost approximately $68 per hour, so a savings of 5% could represent $3.4 million in savings for Webcor. After evaluating the current state, I began to conduct a literature review to determine how to move forward with the project. I found there's no clear best practice for construction resource layout. However, there are a few technologies that are currently being used in the industry. The first is vision tracking, which uses video cameras to detect objects and predict their movement across a construction site. There are 3 types of trackers that are commonly documented. However, the most effective is the kernel-based method, so this will be further considered in my alternatives analysis. Additionally, there's radio frequency identification, or RFID technology. What this does is uses RFID in combination with GPS to track resources across a construction site. Finally, there's 4D technology, which is generally used in a 4D integrated site planning system. This has many features which include resource management, but may be outside the scope of this project. My objectives for this project fall into 3 main categories: data collection, data analysis, and the presentation of my findings to the client. The main deliverables that I hope to present to Webcor at the conclusion of my project are the design of an optimal site resource layout, as well as an action plan for implementing this resource layout and any other improvements that I developed across many different project sites. Additionally, I will present them with a business case that can hopefully be used to encourage their upper management to pursue my suggestions. To complete this project, I will need to apply many industrial engineering tools that I have developed throughout my classes at Cal Poly. First, engineering test design will need to be used to develop a data collection plan and ensure that my findings are statistically significant. Additionally, I've had to do extensive data collection and analysis for many of my classes at Cal Poly with local clients, and this has set me up well for the extensive data collection that I will be doing on this project. General process improvement principles will guide any recommendations that I decide to make to Webcor. The last two skills, facility design and engineering economics, will be crucial in my main two deliverables, which are an action plan for implementing an optimal site resource layout and a business plan for following those recommendations. To move forward with my project, I will be finalizing my data collection procedures and beginning formal data collection over the next few weeks. Then I will develop alternative solutions to this problem and finally present an action plan and business case to Webcor. This concludes my presentation. I look forward to continuing to work with Webcor to improve their field worker efficiency. Thank you for taking the time to watch my presentation.